Vertical circle, derive reaction force. So I've got a circle here, and this is again the sort of situation where you got something coming down into a vertical circle, little cart if you like, and we do the normal, find out the reaction force when it's in the vertical, find out the reaction force when it's in the bottom at the top. What I wanted you to do this time with this exercise was find out the reaction force at that point. Now the reaction force is changing all the time. This is much more complicated than circular motion in the horizontal plane. So at that point, let's put a center on our circle and let's call the angle, sorry about that lack of straight line, theta. It's pretty crap, isn't it? Doesn't matter, we know that's a straight line. Looks better now, just a bit thicker. Alright, so theta is our angle, as usual. mg is straight down. Now the thing is that we can break that mg as usual into two components. We can break it into and let's look at our angles. This is the angle between a line going that way and that way. This one's at a tangent to the circle, so this one would be going towards the radius. So that is also theta. Now that one is 90 degrees, so we have two components there. We've got mg sine theta. Now mg sine theta is actually the force, the tangential force is mg sine theta, and that's what's going to slow down this object. It's all going in that direction, so that force is tangential. You have a force mg cos theta. So mg cos theta goes perpendicular to the rails. So a component of your reaction force is definitely going to be mg cos theta. And it's basically just your normal support force cancelling out the weight force that is perpendicular to the rails. The other part of the weight force was actually the tangential force. So what we're going to end up getting though is we've also got a velocity. So we need an extra bit of force, not just that bit, we need that extra bit there, which is v squared over r times m. That's our centripetal force, and that needs to be on top of our support force. So our actual reaction force from the rails has to have two components. It has to have mg cos theta and m v squared over r. And that's our reaction force from the rails. So it's just a little bit trickier than usual.